The ellipse, part 3. So a friend of mine showed me this. You got a pool table shaped like an ellipse. You put a hole at one focus, and then you shoot the ball from the other focus. No matter how you shoot it, no matter where it goes, it's going to go into the hole. And you know what that means. It means our to-do list has one more thing to do on it. The pool table thing. Starting with our equation and the location of the focus, and these lines, the length of those two segments, of course, is 2a, and then we hit pause and prove this. Tangent. Well, why the tangent? Then the angle difference, and then we work through the algebra, and we have an equation for the angle difference tangent equation. Okay, I guess that'll be useful later, maybe. Back to our ellipse, back to our problem. The problem of showing that one of these lines will be the reflection of the other. Well, the first line has a slope that we can find like this, rise over run. The second line has a slope that we can find like this, rise over run. And the tangent line of the ellipse, well, we can find that too with the derivative and working out the details. There, the slope of the ellipse at that point. Notice that if x and y are both positive, then the slope there will be negative. That's not really what we want, though. We want this, the normal line, the perpendicular line. That will be the opposite inverse. Got it. Get ready. Our job is to prove that this angle is the same as that angle. The law of reflection. If we can prove that, then we can prove the pool table thing. But how do we prove that? Well, let's take a look at this. Totally different lines. Just how, in general, can you find angle alpha here, given the slope of line 1 and the slope of line 2? Well, the first step is to define these angles. And slope is rise over run, so the slope is tangent theta 1 and tangent theta 2. Math with angles. Angles that add up to 180 this way and that way, which tells us that angle alpha is equal to this, the arctangent of slope 1 minus the arctangent of slope 2. And if I knew what slope 1 and slope 2 were, then I could use this equation and be happy, but I don't really know values for slope 1 and slope 2. Instead, I know equations. I can find equations for slope 1 and slope 2. There they are. Yeah, those. So what am I going to do? I'm going to hold off on finding alpha this way and do that instead. You see what those are? Angle differences. I knew that would come in handy. So we rewrite alpha this way. Well, we'll be finding tan alpha technically, but if tan alpha equals tan alpha, that's good enough for us. Good enough for us. Good enough for us. Us, the orange and the yellow. Those were the preliminaries. This is the orange and the yellow. And with the red and the blue taken to the left, the green and the purple to the right, some substitutions, we're good. We're ready to shoot some pool.